Welcome to today's tutorial. Now, I want to teach you how to balance a combustion reaction with just three steps. Three steps. It is extremely easy to solve. And this, my step, you can use it for any combustion reaction. But firstly, you need to understand what a combustion reaction is. When we say a combustion reaction, combustion simply means burning. And what are involved when it comes to combustion reaction or burning? A combustion reaction is a reaction whereby oxygen is added to a particular reactant. So physically in combustion reaction burning occur. So whenever a particular reactant is added to oxygen or oxygen is involved in a particular reaction, this actually happens when oxygen reacts with an hydrocarbon compound or organic compound. And the thing is that physically you see burning. So when you see burning physically or flame physically, it means oxygen is involved in this reaction because oxygen supports combustion. So let's take butane as an example. This is an hydrocarbon C4H10 plus O2. Now you can easily predict the product of a combustion reaction. In any combustion reaction where an hydrocarbon compound and organic compound is involved, both for the hydrocarbon compound and compound of carbon and hydrogen and organic compound are involved, the product is usually carbon dioxide and water. So the product here will be CO2 plus H2O, carbon dioxide and water. Now let's begin. Step one, in any chemical reaction, to balance any chemical reaction, the step one you have to take is count all atoms involved. You count all atoms involved. And mind you, to balance chemical reaction, you don't write numbers as subscripts. No, you don't write numbers here to balance. You only write them here as coefficients. So now let's count the number of atoms you have on both sides. I have four carbon atoms here. I have 10 hydrogen atoms here. And I have two oxygen atoms here. Now let's go to the product side. I have one carbon atom here. I have two hydrogen atoms here. In carbon dioxide, I have two oxygen atoms. Plus in water, I have one oxygen atom, making it a total of three oxygen atoms. That is step one. Now, step two, in combustion reaction, the first thing you need to do, if you start your counting, the first thing you need to do is balance the carbon first. Balance the carbon first. How many carbon atoms do we have here? Four. How many do we have here? One. Now focus on the side that have greater number of carbon atom. It is this left hand side. So which is four. Now four divided by one gives us four. You will now add this four to the side that have fewer carbon atom. So I'm going to add the four to this side. So you can now see now we have four carbon atoms here now and we have four carbon atoms here. So it is balanced. The second thing you need to balance is the hydrogen. How many hydrogens do we have here? 10. How many do we have here? 2. It is not balanced. To balance this now, it will now be focus on the side that have greater hydrogen atom, which is this left hand side. 10 divided by 2 gives us 5. We add the 5 to this side that has fewer number of hydrogen atoms. And now 5 times 2 in balancing of chemical reaction, you always multiply the coefficient by the number of atoms you have. 5 times 2, the coefficient is 5. How many hydrogen atoms do you have here? 2. 5 times 2 becomes 10 in total. So this means that you now have 10 hydrogen atoms in this equation. Now the last thing you need to do now is balance oxygen. Oxygen is always balanced last in combustion reaction. How many oxygen do you have here? 2. How many oxygen do you have here? Initially we had 3 oxygen, isn't it? But now when we added this coefficient, these two coefficients, 4 and 5, the initial oxygen has changed. So now the oxygen we'll be having here now is 4 times 2 is 8. Don't forget this coefficient 4, you multiply it by the number of atoms you have here. 4 times 2 gives you 8, so it becomes 8. This side, the water, in water, 5 times 1 becomes 5. 8 plus 5 gives you 13. So we now have 13 number of oxygen atoms. Now, it is not balanced, isn't it? In the left hand side, we have just only 2. So what you need to do now is the same thing we did for the previous one is what we are going to do in this case. The greater number is at the right hand side here. Divide it by this smaller one. 13 divided by 2 gives you 6.5. 6.5. Now add this 6.5 to this oxygen atom. This is balanced, but it is not allowed in chemistry. Decimal or fractions are not allowed in chemistry. To clear this fraction now, what you need to do is just multiply all the coefficient by 2. You multiply all the coefficient by 2 to clear this fraction. So that will gives us 2C4, abi 2 times 1 is 2C4, H10 plus 2 times 6.5, 13O2, going to 2 times 4, 8CO2 plus 2 times 5, 10H2O. Now let's confirm if it is balanced or not. How many carbon atoms do you have here? 2 times 4 here, it becomes 8. How many hydrogen? This 2 is also affecting this hydrogen atom. 2 times 10 becomes 20. How many oxygen atoms do you have here? This 13 is affecting this. 13 times 2 gives you 26. In the right hand side, how many carbon atoms do you have? This 8 is affecting this carbon. So it becomes 8 times 1, 8. So we have 8 carbon here, 8 carbon here. It is balanced. How many hydrogen atoms do you have there? This 10 is affecting this atom, this hydrogen atoms and this oxygen atom. But we want to balance, we want to confirm if the hydrogen atom is balanced. 10 times 2, that gives you 20. That is balanced. We have 20 here, we have 20 here. Now, let's come to oxygen. In carbon dioxide, how many oxygen atoms do you have here? The coefficient here is affecting this oxygen atom because 8 times 2 gives us 16. In carbon dioxide, we have 16 oxygen atoms. While in water, 10 times 1, we have 10. So when you add this together, it gives you 26. Is it balanced or not? It is balanced. And the funniest thing, the interesting part is this. This thing follows, if you follow this step, you use it to balance any combustion reaction. Just follow my step. You use it to balance any combustion reaction. The first step is count the number of atoms you have. The second step, balance the carbon atom first. The second one, the third one, balance the hydrogen atom next. And the last one, balance the oxygen atom. If you get a decimal or fraction, just multiply that fraction, multiply all three by 2, and it will be cleared. You balance, you have everything balanced. Now, in this case, I'll show you how to balance a combustion reaction where an organic compound is involved. That is compound that contains carbon, hydrogen, and oxygen. Now, we are going to be making use of ethanol as an example. C2H5OH plus O2 going to, don't forget this is a combustion reaction and the product is usually carbon dioxide and water. Now, how do we balance this? The difference between this organic compound and the previous hydrocarbon compound is this. In this organic compound, we have one oxygen atom in it. But in the case of hydrocarbon compound, we do not have any oxygen atom in it. The oxygen atom is acting, was only acting as a reactant here. You get that? But in this case here, the oxygen atom here is inside the organic compound ethanol. So it's in the organic compound ethanol. How do you solve any similar equation like this? Follow me along. Don't forget, we first need to count the number of atoms you have on both sides. How many carbon atoms do you have here? 2. How many hydrogen atoms do you have here? We have 5 here, plus 1 here, that means 6. How many oxygen atoms do you have here? We have 1 oxygen atom in ethanol, and we have 2 oxygen atoms uncombined. That gives us 3. So how many carbon atoms do we have here? 1. How many hydrogen atoms do we have here? 2. How many oxygen atoms do we have here? In carbon dioxide, we have 2 oxygen atoms, whereas in water we have 1. making it a total of three oxygen atoms. Now the next thing now is to balance the carbon first. How many carbon atoms you have? Two. How many do we have here? One. So that gives us two divided by one gives us two. It is balance. So this is balance. We have two carbon here, two carbon here. Now let's balance the hydrogen next. How many hydrogen do you have here? Six. How many do you have here? Two. So that will be six divided by two, which gives us three. Where am I going to add the three? I'll add the three to the side that has fewer number of hydrogen atoms. So I add the three to this side. This becomes three times two. It becomes six. So I have six hydrogen atoms now in the right hand side, and I have six hydrogen atoms in the left hand side. So it is balanced. Now I'm balancing the oxygen last. How many oxygen atoms do I have here? Three. How many do I have here? Don't forget it has changed. Why? Due to the addition of these two coefficients. So it has changed our initial number of oxygen atoms. So the oxygen atoms here becomes 2 times 2, it becomes 4 here. 3 times 1, it becomes 3 here. 4 plus 3 gives us 7. So I have 7 oxygen atoms in the right hand side, and I have 3 oxygen atoms in the left hand side. To balance this now, I'm going to divide 7 divided by 3. Now, don't forget, to balance this now, am I going to divide 7 divided by 3? No, I'm not going to do that, because if I divide 7 with 3, it is going to give me a decimal number. But that decimal number, if you multiply it by 2, it can never be cleared. It cannot be cleared. So anytime you have oxygen atom here, you will not divide the greater oxygen atom with the by the what? The smaller one, because you are not going to get a decimal that will be cleared. The decimal will not be cleared. Now this is 7 divided by 3 will give me 2.33333. And if I have 2.3 here, listen, if I have 2.3 here, 2.3, what can I multiply to clear this 2.3? Nothing. So it's going to look laborious. Do you get now? So this is what we need to do. Don't forget we have one oxygen atoms here in ethanol. Abi, now this 7 we have here, subtract this one from this 7. 7 minus 1 will give us 6. Now we now have 6 oxygen atoms remaining to balance the number of oxygen atoms. So that remaining 6 oxygen atoms you have, you divide it by these 2, this uncombined oxygen you have here. 6 divided by 2 will give us 3. So we add our 3 to this side. Now let's check if this is balanced or not. 3 times 2 here will give us 6. Plus this one you have here gives us 7. Now we now have 7 oxygen atoms here and 7 oxygen atoms here. It is balanced. This is extremely easy. The logic here is the way to balance combustion reaction. Anytime you have oxygen atom involved in the reactant that reacts with oxygen, this is the step you take to balance it. The simple step you take to balance it. You can also use this to balance ethanoic acid. So I'm going to leave you to balance this reaction using the same logic, CO2 plus H2O. Use the same logic above and you will balance the reaction. So in this case now, we have 2 oxygen here. So that will be, you know what it will be? So